Hello everyone. We were learning Hive, wherein we have seen what are the data types prevailing, what is schema on read, what is schema on write and all. Now we shall talk about what are various types of tables in Hive, what are partitions, what are buckets, etc. Now, whenever we are working with Hive, a Hive table is logically made up of data that is being stored and the associated metadata. The data typically resides in HDFS and sometimes it can reside in any of the Hadoop file system, sometimes it can reside in local file system, sometimes you can borrow the S3 from AWS. And Hive stores the metadata in a relational database and not at all in any of the HDFS. So, always it resides in relational database. Now, multiple database or schema support. Suppose I want to work with various namespaces, I want to create various databases. You have the option here, just like SQL. You can create whenever you want a database and use that in order to store the tables of a particular application. Say for example, I am trying to work with student database. You can create a database or namespace for that particular application. Suppose I am working with goods and inventory. In such case, I can create my namespace and database for that particular application. So, multiple database or schema support is prevailing in Hive query language. How do we create, use and drop a database? Just like this structure. Create database, database name. We know this structure in MySQL or SQL. The same structure is used in Hive also. Create database, database name, and once you create a database, how do I use that? Use database name, and maybe you are no longer needing that particular database, you also have the option of dropping a database. And we can fully qualify the table by writing database name dot table. Say for example, I have created student database in which I am trying to use AIML students. Say for example, there is a table called AIML students and my database name is student database. How do I access this particular table? Student database dot AIML students. So, you have the fully qualified name for the tables. And if you are not creating any database, you are just started creating the tables, it goes into a database which is there by default and the name of the database is also default. It goes into the default database. And this is very important with respect to your theoretical examinations. If you are appearing in an interview on Hadoop side and practical wise also. So, this is one of your lab exercise, managed table and external table. Whenever we are working with Hive, there are two types of tables, managed table, external table. By default, whenever we are creating a table in Hive, by default the nature of the table is managed table. So, what is a managed table? What is an external table? What are the major differences between these two? Let us see. So, whenever you are creating a table in Hive, by default Hive will manage the data. So, the table will be called as managed table. What is the meaning of managing the data? Which means that Hive moves the data into its warehouse directory. What is the meaning of this one? Say for example, in HDFS you have created your own folder. Say for example, I take my name as example. There is a folder called SRIDEVI in which I have created a file called sample.txt. Whenever I try to load this sample.txt into any table of Hive from SRIDEVI folder, the file will be moved to the warehouse folder of Hive. So, no longer this file is available in the folder called SRIDEVI. The file will be moved to Hive's warehouse folder. This is called as managing the data. So once we are loading this particular file from Sridevi folder into Hive table, Hive owns the data. Hive takes that file by deleting it from the source location. So Hive is now taking care of that particular data. So you can think of like this, and Hive puts this data as managed data. So that is the reason the table is called as managed table. Who is managing that? Hive is managing the table. So try to go through this. When we are creating a table in Hive, by default Hive will manage the data, which means that Hive moves the data into its warehouse directory. Alternatively, we can work with external table that we will see. The difference between the two table types will be seen during load and drop semantics. I will talk about what are managed tables and external tables with example. Now try to see what is a managed table. When you load data into a managed table, it is moved into Hive's warehouse directory. For example, try to see these queries. What is the statement? Create table, managed table. What is the name of the table I am using? Managed underscore table. How many fields are there? Single field is there, dummy. And what is the data type of the field? String. After creating the table, what am I saying? Load data in path. Right now the file is in this folder under user, under Tom, under the file name is data.txt, into table, managed table. You are trying to load this file from this folder into this table. The moment you make it as, by default I did not specify anything, I just told create table. Whenever you just use create table, it is understood as you are trying to work with managed tables. If it is external table, there is a separate keyword external. So if we are not mentioning anything between create and table, it is to be understood as managed table. Not because of this word. This word is just to give a name to the table. You can give sample table, my table, any name. Just because we gave their managed underscore table, it will not become a managed table. How do we understand who is a managed table? Between create and table, you did not specify any keyword. With that create table, the default create table if you have given, that is understood as managed table. Now, whenever you try to load this from this folder, the file data.txt will be moved into user Hive warehouse. Now under warehouse, it will create a folder by name of this table. What is name of this table? Managed underscore table. So in this table, it will try to, in this folder, it will try to put this file data.txt. So if you go to user/tom and try to list out for data.txt, you will not find the file. Now load operation is very fast. It will just move the file from one location to the other location. It will not check for the file whether it is matching the syntax of the table or not. All such things will not be taken care. Suppose you are trying to read the data from the file data.txt, and in this, say for example, I have some binary information. Consider for example. And what is the structure of the table I have given? There is a single field called dummy and the data type is string. Suppose boolean is there in the file. Boolean cannot be stored in any other data type. We have learnt boolean cannot be casted to any other data type. So there is a mismatch of schema and the data. What I am trying to say is, in data.txt, say for example, I have used boolean data, true, false, and I am trying to load it into this table which has a single field of data type string. When you are trying to read the data, load this data, schema is saying string data type, the file internally has boolean data type, the schema mismatch occurs. In such case, it will try to put them as null values. Whenever there is a schema mismatch, the query returns null value. Now, where the difference of managed table comes, whenever you try to say drop table, table name, what it will do? It will delete the table schema, the loaded data, and the file which is moved from the original location to the warehouse folder. All of them will be dropped, all of them will be deleted. So what is happening whenever you are working with managed table? From the source location, the file is moved to warehouse. So I don't have my original file in the original location. It is moved to Hive's warehouse. Whenever you are dropping the table, everything will be deleted. So you are losing your original data also. So if you don't mind losing the files, whenever you are dropping the tables, you can go for managed table, right? Similarly, whenever you are performing drop, wherever the file is there, you are not having that data anymore, not in source location, not in the moved location called Hive's warehouse. External tables, whenever you are trying to work with external tables, try to see what will happen. Create, what is the keyword we are giving here? Create external table. You specify this keyword explicitly, the table will be maintained as an external table. You are omitting this, by default it will be a managed table. Now create external table. What is the name of the table we are giving? External table. And you are working with the single field location. You specify what is the location. You can specify where the table should be maintained, /user/tom external underscore table. Whenever you specify that, the file will not be moved into warehouse of Hive directory. And how do I store the data? Load data in path from this directory into what table? External table. Now, whenever you work with external tables, Hive knows file from the original location to warehouse, all those things will not happen. Whenever you drop the schema also, it will not delete the original file, it will delete only the metadata which is maintained by Hive. So your data is important to you, you don't want to lose it in the source location, try to work with external tables. Otherwise, even if you lose the data, you don't mind, go for managed tables. Hive will take care of deleting everything when you drop the schema. And as I mentioned initially, these definitions of managed table, external table are very important with respect to lab examination as well as theoretical point of view. Now, as a rule of thumb, when to use managed tables, when to use external tables. And partitions, whenever we are working with partitions, again this is also very important with respect to examination as well as lab exercise. So whenever we are working with partitions, what we do is we have a huge data file. Based on a particular field, I want to slice my data. In such cases, we go for partitioning. You have static partitioning, dynamic partitioning, various steps are there in order to create these partitions. Everything will be shown to you in the PPT, whichever is following for lab exercise. Now, Hive organizes the tables into partitions. As I told, you are trying to slice the data. I will show you. Say for example, I have a table called logs which has timestamp as well as complete line of that particular log record, which is partitioned by date as well as country. Whenever you are trying to work with partitions, the partitioning attributes are part of this table, but you need not mention them in the create statement. You just mention them in the partitioned clause. Right? Then whenever I load my particular text file into this particular table, I have to specify what is the date and for which country you are partitioning it. So if you see this one, for January 2001, country GB, one partition will be created. Similarly, suppose there is one more country US on the same date, another partition will be created. So based on the country code, multiple partitions will be created for January 1st. If there are 5 countries data on January 1st, you can try to create 5 partitions for one for each country. So whenever I want to see who is having multiple records in US, only that particular partition will be accessed. So I am not accessing the entire database, only that particular size slice whichever is matching my requirement. Thereby you are trying to save the query answering time. So whenever I work, this is how the partitions will be created. In the folder warehouse, by name of the partition, what is the name of the partition we have given? Logs. So under Hive's warehouse, by name logs, a folder will be created in which you are trying to work with multiple partitions like this. Similarly, whenever you try to list out, the partitions will be listed based on the date as well as the country. Just like you have given them in the partition creation, it will try to save them with the same name. Date is equal to 2001 0101 slash country is GB likewise. And whenever you want to see the data, this is how you give: select timestamp date line from logs where country is equal to GB. Now which file it will access? Only the first file, not all the files. So whenever you are working with select EMP, select star from EMP, you are accessing the entire employee table. Instead here it is like you are partitioning the data based on the department the employee is working in. And whenever you access that, only that particular department's database slice will be accessed. And similarly, apart from partitions, you have one more concept called buckets. You can try to put your data into buckets or you can organize them into buckets. First one is to enable more efficient queries. Bucket imposes extra structure on the table and Hive wants to take advantage of this. Similarly, joins can be performed on bucketed table, various map side joins can be maintained, and bucket table makes it sampling event. Access only a particular piece of data can be done very efficiently. So how do we create the buckets? If you see, we can use clustered by clause to specify the columns to buckets and the number of buckets. Now if you see this one, create table bucketed users, ID and name. There are two attributes, clustered by. So what is the bucketing column here? ID. ID of the user should be used as clustering item or the bucketing ID. And into how many buckets are we dividing the data? 4 buckets. If there are 20 records in the file, every record will be part of one or the other bucket, right? Now select star from users. If I give, suppose I have 4 rows in this, I want to put them into bucketed users. Insert overwrite table bucketed users, select star from users. So it is trying to take this data and put them into the bucketed users. How does it fill? Physically, you will find them in a warehouse folder with bucketed underscore users, and each file, each one will try to create 4 files. Because you told 4 buckets are to be created, for every bucket one file will be maintained in Hive warehouse. And storage formats, various types of file formats are there, one for serialization, one for deserialization, and in short we call it as SRIDEVI, stands for serialization and deserialization. And when it is acting as a deserializer, whenever you are trying to query the table, it will try to deserialize a row of data from bytes in the file to objects internally maintained by Hive. What is the meaning of this one? Originally my file is in text file, right? When it will be loaded into Hive table structure, whenever you are issuing a query, then only the data from the text file will be loaded into the table. When I say select star from log records, until I give this query, the file will be in log.txt. Whenever I give this query, the data from this file will be loaded into log records table, then it will try to show me the log records in an SQL format. So, the text file is now converted into Hive query language objects, deserialization. Similarly, whenever you are trying to work with the serialization, you are trying to store the data from the table into a file. So, we call it as serialization of Hive. So, default storage format is delimited text. What is the delimited text we are using here? Default one is 1 row per line will be maintained in the file. So, whenever you are working with Hive, you should be learning what are external tables, what are managed tables, what are static partitions, what are dynamic partitions, what are buckets. About storage formats, you will learn more when you are learning about Avro, Parquet, various file formats you will be learning as part of your 4th unit.